Right? So these bounds are y in terms of x. All right, so they're functions of y with respect to x, which means that they're x equations, which actually is the reverse of what I just said. I don't know why I said that. I was just like, I was trying to be fancy and I screwed it up. They're just x values. All right, so that's an issue because these are clearly not x values. Those are u's. Fun fact of the day, FFOTD. So what I want are new boundaries that are in terms of u. Now, technically you don't need to do that. You can take the antiderivative, reverse substitute, put your x's back in, and then work with the original bounds. But it's going to be much nicer to work with new bounds that are u-based. So what do? We take our u function, because that's a relationship between x and u, find what u would be if x is equal to 4, and find what u would be if x was equal to negative 2. 4 cubed plus 8, negative 2 cubed plus 8. Sometimes, this is not always true, I don't want to promise this, but sometimes the bounds get simpler. Like in this case, the lower bound is now a bound of 0. The upper bound is not nice. We're stuck with that. That's what, 72? But anytime you can incorporate a 0 into a calculation, it can't be a bad thing. So the antiderivative would be, well, I have the 1/3 because it was there the whole time. 1/3 u cubed on the interval of 0 to 72. And so now I don't have to worry about replacing the u with x cubed plus 8 just to plug in the negative 2 and 4. I've already done that. So 1/3 times 1/3 72 cubed minus 1/3 0 cubed, which hopefully on your own you wouldn't write because you know you plug in a 0, it's going to 0. So this simplifies down to 1/9 times 72 cubed, which, you know, chuck it into your calculator, get an answer, but it's going to be astronomically large to the point where you're probably just better off leaving it like this. Okay, so that's actually where I'm going to leave it. Okay, so some of these problems, actually, I think, well, this one definitely looks like a repeat. Some of them are repeats of problems that we've done before, or at least similar enough that you're going to have a leg up when you try to do them on your own. So I have no guilt about doing meh, meh, and meh, so that you can practice these on your own and we'll tackle them together in class on Monday, at which point I'll probably be late because of flooding. I think it'll be flooding this time. That's why I'll be late.